In this video, I'm going to look at one of the applications of differentiation, which is finding the equation of a tangent to a curve. In this example, I'm going to find the equation of the tangent to the curve f of x equals 3x cubed minus 2 at the point where x is equal to negative 1. Now, just for reference sake, I'll call this first equation equation 1 so we can refer back to it a little bit later on. Firstly, in order to find the equation of the tangent, we need to find the gradient of the tangent line at this point where x is equal to negative 1. So firstly, we'll find the derivative of equation 1. And the derivative of equation 1 we write down as f dashed of x, and it's equal to 3 by 3x squared, and of course the derivative of 2 is just 0, so just 3 by 3x squared. If we simplify that, it becomes 9x squared. So at the point where x is equal to negative 1, f dashed of minus 1 is equal to 9 times minus 1 squared, and that's equal to 9. So the gradient of the tangent we now know to be 9. Let's let the equation of the tangent be of the form y equals mx plus c. That's just the standard form for a straight line, and we know the tangent's going to be a straight line. Now we already know the value of m in this equation, m being the gradient of course. So we know that our equation is going to be y equals 9x plus c. M is the gradient, so y equals 9x plus c. And I'll call that equation 2, again so we can refer back to it later. Now we need to find the value of c, and we go about doing that by referring back to equation 1. We need to actually find f of negative 1, so we need to substitute x equals negative 1 into our original equation, and that gives us f of x equals 3 times minus 1 cubed minus 2, and that's equal to minus 3 minus 2 or minus 5. So we now know that negative 1 minus 5 is a point on the original curve, and it's also a point on the tangent. And if we have a look at the graph, we can see this point, the tangent point, at x equals negative 1, y equals negative 5. That point is a point on the straight line, which is the tangent, and it's also a point on our original curve. So if we substitute x equals minus 1, y equals minus 5, or that point, into the equation for our tangent, which is equation 2, then we get minus 5 equals 9 times negative 1 plus c, and quickly rearrange that, we can see that c is equal to positive 4. So the equation for the tangent line that we've been looking for is y equals 9x plus 4.
For more free tutorials and the PDF for this tutorial, visit www.handwrittentutorials.com.